How are we doing? We putting down some answers? I like how Jordan is starting off. She's got 3 blank spaces because she knows it is a 3-digit code. Okay? All right. So let's talk about this. Joel forgot his 3-number lock combination. So right there, you should be going, whoops, that's a little wide. You should be doing 1, 2, 3. I really think that is helpful to put down the blank spaces so you know what we're talking about. Okay? Tristan, can you go to bell work day 7? He knows the lock only has numbers 0 through 39 on it. Now, the skills check yesterday, a lot of people missed this. How many numbers are there from 0 to 39? 40. It is not 39. You have 1 through 39, which is 39 numbers, plus the 0. So it's always one more than that number. So that is 40 numbers. Okay? That's good to keep in mind. 40 numbers. He knows that the first number is a single digit. Single digits. So what values could I have for single digits? 0 through 9. Now when you count 0 through 9, how many total digits is that? 10. So that 10, you have 10 possibilities for that first place number. Yes, but this isn't saying it is a 10. That says there are 10 options. Okay, we're talking about number of options. Is everybody with me? And I appreciate you saying that. That is not the number. That is how many we have to choose from. Okay, the second number is even. So how many numbers do we have totaled to choose from? 40. Right? And every other number, when you count, is odd or even. So we're taking those 40 numbers and dividing them into 2 different groups. Because if you start with 0, 0 is even, 1's odd, 2 is even, 3 is odd, back and forth. So it's 40 divided by 2, because those groups are odds and evens, which means you're going to have 20 in each group. So you have 20 even numbers, and you would also have 20 odd numbers because they're all in a row, successive. Does that make sense? Yeah, so if they want to know how many odds, how many evens, take the whole amount that you have and divide it by 2. All right, the third number is either a 13, a 14, or a 15. Jada, how many choices is that? 3. Excellent. So we have 3 choices for the third spot, 20 even numbers for the second spot, and 10 for the first spot. What do I do with these numbers to figure out how many possible combinations there are? Multiply, yes. So 10 times 20 is 200. 200 times 3 is 600. 600 combinations. Did anybody happen to have 600 before we got there? Very good. Excellent. Does it make a little bit more sense now for those of you that didn't have 600? Okay. Now, is this a probability? Is that a probability? No. That's just how many outcomes, how many total. So this would be like your denominator. Remember, a probability is your number of successes out of the total number. So if we were to have a probability, this would go on the bottom. But it is not a probability, it's just how many outcomes. Okay? All right. Is that a little bit more clear for some? Okay. Number 2, 2 students were asked to solve the equation. Are either of them correct? Well, what do you notice? They start by writing the problem. Look at their second line. Is the second line the same? No. So that means there's a change right away. Which one is correct on that second line and why? Joshua, yeah, because what are we doing with this -2? That's right. And a -2 times the -4 is a +8. Daniel did not do that, so Daniel's is not correct. Now, Joshua, maybe he made a mistake down below, so let's check. So we have +8 equals 48, -8, -8. That's good. -2x equals 40 divided by -2. X equals 20. Is that correct? Yes. So explain your reasoning in detail. Joshua distributed correctly that -2 times -4 equals the +8. Something like that. Okay? Any questions about that? Okay, let's go back into our notes. We are starting on the next section of 7.3, compound probability. Compound probability. Oops, not that one. Not that one. What page is that for you guys? Page 8. Thank you. So page 8, it should say 7.3, compound and conditional probability. We're going to talk about compound probability. Okay? Have you ever heard of compound sentences in English? Yeah, what does it mean? Do you remember? No. Right. Say it a little bit louder, Jeffrey. Yeah, a combination of two sentences, usually joined by certain words called conjunctions. Do you remember any of the conjunctions? And, but, or. Well, we are going to focus on the and. So compound sentences are like compound probability. Similarly, we're going to focus on the and. So it says, well, what if more than one coin is flipped? Or more than one die is rolled? Or you have to pick multiple marbles from a jar? How would you calculate the probabilities of multiple events occurring? We would use compound probability. Probability. Okay. So compound probability is where you multiply the independent events, together. How do I want to say this? At the same time. Now, we'll get a little bit more into this word independent. Oh, I said independence. It should be independent events. Independent events together at the same time. So you've got two things happening here in a compound probability. Okay? Kendra, are you okay? Okay. So, number 1, a coin is tossed and a 6-sided die is rolled together. What's the probability that the coin shows tails and the die shows a 3? Okay? So we're going to write this as the probability of getting tails and getting a 3. Now, we've seen that symbol for and before. That was in a table, right? And in the table, we had to look for the intersection. Well, we don't have a table here. So these are independent events. However you toss the coin has no effect on how we roll that die. All right? So the probability of tails and 3 is going to be the probability of getting tails times the probability of getting a 3 on that die. Okay? So, and remember, these are probabilities. And what is that? It's the number of what? Successes over total. Yes. So the probability of getting a tails on a coin. How many successes can you have when you flip that? What is it? Not 1.5. If you flip a coin, how many total choices do you have? 2 on the coin, right? You have heads on one side.
Are we going for heads or tails?
We're going for tails. Did I say heads? We're going for tails right here. So the probability of getting tails, you have 2 sides to choose from. And what's the probability? How many successes can you have when you flip that coin? 1. So that is 1 out of 2. Okay? 1 out of 2. Madeline, come on. Are you all finished? Okay. Times, what's the probability of rolling a 3 on a die? 1 out of 6. Now, if you remember your multiplication, you multiply top times top when it comes to fractions and bottom times bottom. So 1 times 1 is 1, and 2 times 6 is 12. So the probability of getting both of those is 1/12. Okay? Any questions on that? Any questions on that? All right, let's go to the second one. Letter B, what's the probability that the coin shows heads? Come on, guys. Hey, come on. What is the probability that the coin shows heads and the die shows an odd number? So this would be the probability of getting heads and an odd number. So that's going to be the probability of heads times the probability of getting an odd number. All right, what's the probability of getting heads on a coin? What is it? 1. 1 is not a probability. Well, it is. 1 out of 2. There you go. So that's 1 out of 2 for the heads. You've got 2 choices, and the heads is one of the 2 times an odd number on the coin. What are our odd numbers? Not on a coin, on a die. 1, 3, and 5. How many successes is that? 3 out of 6. If you're rolling a die, it's 3 out of 6, right? You were given the answer? All right, so multiply across. Top times top, Bottom times bottom, 1 times 3 is 3, 2 times 6 is 12. All right. We could simplify this. We could divide by 3 over 3 and reduce it to 1 out of 4. Okay? But I think for right now, I will just take 3 out of 12. Any question about that? Now, you could draw it up. You know, if you were unsure, you could have tails here, and we could have a 1, a 2, a 3, a 4, a 5, and a 6. So for the first one, tails and a 3. Tails and a 3. That's for tails. And then you could do the same thing for heads. We have 1, 2, 3, 4, 5, and 6. So to get a tails and a 3, that is 1 success out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's another way to look at it. That's what we're talking about. I know I'm out. I don't have any more right now. There's paper towels over there. Yeah. And the heads in an odd number. So over here, heads in an odd number, I could have this head with a 1, this head with a 3, and this head with a 5. That is 3 out of the total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 out of 12. So this is just showing you with a picture what we're talking about. All right, let's go to number 2. We're flipping a fair coin. What is the probability of the coin landing on heads 5 times in a row? 5 times in a row. I'm going to put some blanks down. How many blanks am I going to put down? 5. 1, 2, 3, 4, 5. Again, I strongly recommend you do this. Okay? A fair coin just means it's got heads on one side, tails on the other. So we're looking for a heads 5 times in a row. It is a probability. What's the probability of getting heads on the first toss? 1 out of 2. If I toss the coin again, what's the probability of getting a heads on the second toss? 1 out of 2. You mean whatever I got on the first one does not affect my second toss? No. What about for the third one? 1 out of 2. And the fourth one, 1 out of 2. And the fifth one, 1 out of 2. So when you are multiplying a bunch of fractions together, again, multiply all the top numbers, the numerators. 1 times 1 times 1 times 1 is 1. And 2 times 2 times 2 times 2 times 2, 4, 2, 8, 2, 16, over 32. Yes? Yes. You also could have written that as 1/2, 1 divided by 2, raised to the 5th power. It would still give you 1 out of 32. Okay? So, I want to tell you here, maybe not here, we'll keep going. Any questions about those first two? All right, number 3. We got our marbles now. A jar contains 5 blue, 2 purple, and 6 green marbles. You have to choose 2 marbles. What is the probability that you get a blue marble the first time and a green marble the second time? Okay. Well, in the first one, we're talking about with replacement. That means you are putting the first marble back into the jar. First marble, whatever it is you pick, goes back in the jar. All right? How many times am I drawing from that jar? How many times? 2. So I'm going to put 2 blanks here to help me out. All right, so the first one, I am looking for, let's probably get a blue. So how many successes do I have? I got to do a fraction here. How many successes? What number goes in the top here? 5, because I have 5 blue marbles, right? How many total marbles do I have to choose from? 13. That's 5 plus 2 is 7 plus 6 is 13. 5 plus 2 plus 7, 13. So that is the probability that I'm going to select a blue marble that first time I put my hand in the jar. Doesn't mean I'm going to get one, but those are the probabilities, the odds, kind of. Now, then it says with replacement, we're going to take whatever marble we get, we put it back in the jar. So how many marbles do I have now for my second draw? How many marbles total? How many marbles total do I have?
With replacement?
With replacement. I still have 13, right? Because I put that marble back in the jar. So I still have 13. And how many blue? No, this time I want a green marble. I want to pick a green marble. So I would have 6. And what do you think I'm going to do with these? We're going to multiply. So 5 times 6, 30, and 13 times 13, 169. That is your probability. With replacement means you put it back in the jar. Without replacement, you don't put the first marble in the jar.
So basically, we subtract 5 from the 13 and make the second fraction, or?
No, not quite. We'll talk about it. You're on there. I like how you're thinking, though. How many times am I going to draw from that jar total? 2. So I'm going to give myself 2 spaces just so I can keep it straight. First time, I want a blue marble. How many blue marbles do I have? 5. And how many total marbles do I have? 13. Now, I'm going to take one out. I am not putting it back in the jar. So now I have 12 marbles total because I am not putting it back in. And I want a green marble. We don't care what I got for the first one. What's the probability that I would get a green marble? 6. So multiply those together. 5 times 6 is 30. And 13 times 12 is 156. So what changed between replacement and without replacement? Yeah, the total number on the second draw. So without replacement, you are not putting it back in. You are keeping it out. You have 1 less marble. Okay, you have 1 less marble here. Questions on that? All right, number 4, the probability of rain on Monday. Probability of rain on Monday is 0.1. That's 1/10. The probability of rain on Tuesday is 0.8. Probability of rain on Tuesday is 0.8. I should have put over here. Is 0.1. What is the probability of rain on both Monday and Tuesday? So this is that and statement. So the probability of rain on Monday, probability of rain on Tuesday is the probability of rain on both.
How's that a probability?
Because probabilities can also be decimals and percents. We deal with them in fractions. But at the very, very beginning, we said they could be percentages, they could be decimals, because you can switch a decimal to a fraction. Okay? So the probability of rain on Monday and rain on Tuesday, I'm going to multiply these together. Give me a second. 0.1 times 0.8 should give you 0.08. Is that right? Yes, question?
I have a question about that. Can I go to that?
Yes, if you have a pass. Yes.
So, like, this is just converted into a fraction originally.
You can,
Like,
and
make that 1/10 off of that,
oh yeah,
and 8/10 off of that, then just multiply those.
you can, but I mean, they've given it to you as a decimal. What I said at the very beginning, and you might not remember, is that we, like I said, can do percentages, we can have probabilities in fractions and decimals. We are focusing on the fractions mostly, but yes, 1/10 is 1/10 this way, 1 divided by 10 times 8 divided by 10. And we're just going to keep it in decimal form when they give it to you in decimal form. Okay? So yes, you can switch it, but there's no need to. Now, do you have have you filled out one of those before? Okay, go to the behind my desk and upper right hand drawer, when you go behind my desk, there should be not a pad of passes, that top, right? There should be like green passes that have several things on them. They're just separate. Grab one of those and put your name at the top. All right, so use the table to the right to answer the following questions. Do you find one? Yes. It says, what is the probability that a person is male and left-handed? Male and left-handed. Remember, these are independent. They have nothing to do with each other. So you find the probability that someone is male, and in this case, they say that is 0.49. And that means we're going to multiply the probability that they are left-handed, 0.13. Use your calculator and multiply those together. Tell me what you get. 0.0367. Oh, you can say it right here. 637. Okay. 637. Okay. What you should notice, and usually you'll fill this out. That's okay. And then that way I just go boom. And then you just put it behind the first period in that little box. When you multiply, when you multiply numbers that are less than 1 times another number that's less than 1, you're going to get an even smaller number because they're not whole numbers. Okay? All right, let's take a look at letter B. Letter B. What's the probability? Oh, yes. What's the probability, that a person is male, left-handed, and white? So we need to do all three of those. So that is going to be male, probability that they are male, why is that kind of weird, is 0.49 times the probability that they are left-handed, which is 0.13 times the probability that they are white. Probability that they are white is 0.75. Multiply all of those together on your calculator and tell me what you get. 0.047. Did you say 4? No? What'd you say?
That's what I said.
0.04765.
775.
0.4